Okay, we're on 6-3, properties of slope. The big idea, you can read it, I'll read it with you. The slope of a line can be determined by examining the graph. Only one line through a point has a particular slope. We've got this idea of pitch of a roof, which is a slope evaluation. It says how much it changes per unit dimension, so it's 5/12 of an inch up for every inch across. So as we move along, our change in height per unit change is 5/12. That is our property of slope. So I guess we're done with this one, right? Maybe not. So let's take a look at some graphs. And I've got a few examples for you that are not in the book. Again, you do need to read this. If I sound repetitive, I am. There's some things in here that you will need to know for sure. So 6-3, this is our properties of slope. And one of the things I wanted to mention is that the slope of a line is the change in height. On a graph, it is the change in height as we move from left to right. It's a reflection of how much that line changes for every unit interval movement. That's our slope. Now you remember earlier I used the letter M for slope, and you might be wondering where this whole idea of M came from. I don't know. I've looked it up. It looks like it was created in the 1800s. Why M? I couldn't tell you, but it is something we use pretty routinely here in the US when we're doing slope. So let's take a look at our first example here. We want to graph a line that passes through -3, -2 with a slope of 2. Remember, for a given line with a given slope through a given point, there's only one line. Excuse me, let me redo that. For a given point and a slope, there's only one line. So if we're given the point and slope, we've only got one line we could draw. So we got to find -3, -2 on the graph. We go here, we're on units of 1. So this will be 1, 2, 3, negative, negative, negative. And this would be -1, -2. So -2, 3, going to be that point right about there. The slope is 2. That's a positive 2. That tells us as I move from left to right, for every unit change I move, it goes up 2 units. So that's the change in height is up 2. So I go over here and I have another point here at 2. I go to here, I go up. Got another point. So now I've got 3 points. That's more than I really need. And I can now draw my line. I would put some little arrows on the end to indicate that it goes forever. But this is the line given this information. Okay, any questions on that? Okay. Let's go on to the next one. And here in this example, we're dealing with stairs, and each flight of stairs is 8 inches in height. That is, thus each stair adds 8 inches to the height of the staircase. Graph the relation between the number of stairs to the height of the staircase. Well, this is a little bit different problem in that each step goes up by 8. And so as we go through steps and height, so our x-axis will be steps, and this will be height. And this is clearly a quadrant 1 problem. Remember, this is quadrant 1, and this is 2 and 3 and 4. But quadrant 1, because if I have no steps, I have no height. So I can never go to where x is 0. Now I suppose I could have steps that go downward, but in this case it adds 8 inches to the height, so I'm going upward. So at 0, no steps, I've got nothing. For my first step, I go up by 8. So 1, 2, 3, 4, 5, 6, 7, 8. You know, I think I'm going to run out of room on this, so I'm going to change the units here to fours. So 4, 8, 12, 16, 20, 24. So my first one will be here, my second one at 16, my third one at 24. Now I could keep going with this. I don't know how high this staircase is, but I've plotted the points. I'm not going to connect them because you either have a step or you don't. There's nothing in between it. So you've stepped up, and it's what we would call discrete data. We don't connect these dots, we just plot them as individual points. And this is our graph of our relationship between the number of steps and the height that you've gone up. That's our second example. Got one more for you. Let me make sure this is gone. And in this one, we're looking at draw a line through the point -1, 3 with a slope of 0. And this is in the section in the book about zero slope and undefined slope. So with a slope of 0 is a horizontal line. That basically means for a slope of 0, as I move from right to left, there is no change in height. So I want to draw a line through the point -1, 3. So if this is -1, that's 1, 2, 3. Here's my point -1, 3. And a slope of 0 is just this horizontal line. That goes across here. We'll put some arrows on the end. And we've done it. We've drawn a line through -1, 3 with a slope of 0. Well, what would happen in this one if we were asked to, let's say, draw a line through, let's pick 5, 2 with an undefined slope? Well, undefined slope means that as I move from right to left, I can't move from right to left because there is no ability to move. It's simply a vertical line is undefined, and since I can't go right to left, it's kind of part of why we say it's undefined. Let's count on 1, 2, 3, 4, 5, 2. So here's our point at 5, 2. If we draw our line through there, there we go. We've got our line with undefined slope through the point 5, 2. Now the 5, 2 line is a vertical line, and if we think about slope as being as you move from right to left, what's the change in height? Well, I can't move from right to left across this line because it's just all height or down depending on your viewpoint. Whereas in this one I can move from right to left and I have no change height with the horizontal line. So the horizontal line is like looking out at the horizon. The vertical line is like looking up or down or following a jet going straight up or something, or a rocket. Those are our undefined slope, vertical line, zero slope, horizontal line. That's it for our lesson. That's what I've got for you. Covering the ideas, applying the math is the work you got to do. See you in here for the mastery quiz. Remember, bring in your questions. Love to talk to you about them.